Do you think you kind of got a grasp of the timeline of the universe? Well, think again, bud. The James Webb Space Telescope has been charting the uncharted, and let me tell you, it has unearthed something that has sent shockwaves through the scientific community. Scientists and astronomers have long debated the very essence of our universe's birth, delving into theories and hypotheses to keep them awake at night. But just when they thought that they had a grasp on it all, along comes the mighty James Webb Space Telescope, with the revelation that could turn everything we know about our cosmic origins upside down. Now get ready for this mind-bending twist. The existence of time itself is being put to the ultimate test. Brace yourselves, because the James Webb Space Telescope has made a discovery so profound, so mind-boggling that it challenges the very fabric of our understanding. But what did it find, Mr. YouTube man? Well, it's something that literally nobody saw coming, widowy. A revelation that dares to question the very existence of time as we know it. So, join us on this extraordinary journey as we delve into this groundbreaking discovery together. We'll solve the cosmic puzzle that has scientists baffled and redefine how we think about time itself. That's right, we're gonna solve the puzzle right here, right now. I'm so smart. Anyways, get ready to have your reality shattered and your imagination ignited as we explore the stunning revelation that this James Webb Space Telescope has unleashed upon the universe. Are you prepared to question everything you thought you knew? Buckle up, folks, because this one is a cosmic roller coaster that you're not going to want to miss. Welcome to the complicated world where time might just cease to exist. I don't know, I just like doing funny voices. So, the captivating images captured by the revolutionary James Webb Space Telescope have sent shockwaves through the realm of cosmology, disrupting the long-standing Big Bang theory that has shaped our understanding of the universe. These electrifying visuals, while breathtaking to the untrained eye, have stirred up a completely different reaction amongst the most seasoned astronomers and cosmologists. As these images were meticulously analyzed, a series of technical papers emerged, revealing astonishing revelations that challenged the very foundations of the Big Bang theory. Galaxies, some unexpectedly small, remarkably smooth, and unbelievably ancient, were shown in these photographs, causing quite a stir. The surprises didn't end there, though, and not all were met with enthusiasm. In fact, one paper boldly bore the title Panic, expressing the profound impact of this discovery. The reason behind the experts' panic lies in the constant contradiction these images pose to the long-held Big Bang theory. This hypothesis, defended by numerous scientists for decades, now faces an unsettling challenge. If the foundation of our understanding, the Big Bang, crumbles, what other fundamental truths might be called into question? That's the question. The consequences are enormous, and astronomers from all over the world are trying to make any kind of sense of this alarming development. Alison Kirkpatrick, an esteemed astronomer from the University of Kansas, captured the collective sentiment when she confessed, "Right now, I find myself lying awake at 3 a.m. and wondering if everything I've ever done is wrong." The implications are simple to understand. These galaxies seen in the photos are fundamentally incompatible with the Big Bang theory because they're too smooth, too old, too little, and too many. According to the established understanding of the expanding universe, as space stretches, galaxies and objects within it should appear larger as their light travels a greater distance. However, the James Webb Space Telescope has turned this notion on its head. The images it captures reveal objects diminishing in size as their distance from us increases. Even galaxies with greater mass and brightness than our own Milky Way appear 2 to 3 times smaller in the JWST images compared to those captured by the Hubble Space Telescope. Additionally, the redshifts observed in these new galaxies are 2 to 3 times greater, contradicting the expectations of an expanding universe. These perplexing facts challenge the very essence of the Big Bang theory and its perspective on an expanding universe. Among these intriguing findings, one particular galaxy known as Glass Z12, or GHZ2, caught the attention of researchers. Normally brighter than our Milky Way, it was astonishingly observed to have a radius of only 300 light-years, which is 150 times smaller than our galaxy. Its surface brightness surpasses any known galaxy in our local universe by a shocking factor of, 600. So when combined with other galaxies captured by the JWST, it becomes pretty evident that these tiny and smooth galaxies don't align with the cosmic notion of expansion. In essence, they challenge the existence of the Big Bang itself. The implications of these groundbreaking discoveries are far-reaching, leaving astronomers and cosmologists alike questioning the very fabric of our understanding of, well, the universe. The quest to reevaluate the origins of the universe has taken an unexpected turn, and the momentous consequences of these discoveries will definitely keep vibrating through the scientific community. Scientists who support the Big Bang Theory have been relying on the Hubble Space Telescope's images to confirm their assumptions about the existence of the ultra-dense Mighty Mouse galaxies. However, the James Webb Space Telescope has taken things to a whole new level. These theorists propose that these teensy tiny galaxies grow and evolve by colliding or spreading out. But here's the twist. The JWST discovery has shattered this far-out scenario. Big Bang theorists anticipate that these collisions would result in damaged galaxies. But the JWST only found gorgeously complete spiral shapes and smooth disks, which are similar to the galaxies that we see today. So what does that mean? Well, the data has effectively debunked the merger theory. Without significant mergers, it becomes basically impossible for tiny galaxies to grow 100 times larger. It implies that these galaxies were not small to begin with. This revelation strikes at the heart of the expanding universe theory. If there is no optical illusion, then there is no expansion. And if there is no expansion, then it questions the very existence of the Big Bang. As you can imagine, that caused quite a bit of a stir amongst Big Bang supporters. The presence of tiny, smooth galaxies suggested that there was no Big Bang after all. And when we consider the age and abundance of galaxies, it only adds weight to that same conclusion. Also, the James Webb Space Telescope captures images in the infrared part of the spectrum using various filters, which enables astronomers to see the colors of distant galaxies, which in turn helps estimate the age of stars within them. According to the Big Bang Theory, these far-off galaxies should be observed as they were around 400 to 5 million years after the universe's birth. However, some of these galaxies have already displayed stellar populations of over 1 billion years old, which poses a significant problem because nothing could have existed before the Big Bang, right? The mere presence of these galaxies contradicts the occurrence of the Big Bang. Furthermore, astronomers expected to find fewer galaxies as the JWST peered deeper and deeper into space and further back into time. The surprises don't end there. Recent research challenges the notion of a dark age in the cosmos. Images taken by the JWST demonstrate that galaxies as large as the Milky Way were already common just a few 100 million years after the theorized Big Bang. In fact, the number of observed galaxies at redshifts of more than 10 is at least 100,000 times greater than what theorists predicted. The formation of so many large galaxies in such a short span of time is highly unbelievable. Consequently, this further supports the notion that the Big Bang didn't actually happen, raising profound questions about the concept of time itself. See, according to some theories, time is essentially a human invention that helps us distinguish between the present and the past as we perceive it. These esteemed scientists suggest that everything that's ever happened or will happen is happening simultaneously. The concept of time becomes an illusion, constructed by human memories. The principles of physics do not, however, mandate that time must always advance as we perceive it. Some proponents of the Big Crunch idea contend that it may just as easily move backwards. According to this theory, as the universe stops expanding and begins contracting, time would also reverse. As the universe grows smaller and hotter, a reversal of time may be inevitable. So, imagine the opposite of the Big Bang, the universe heating up and shrinking. Eventually, everything would collapse back into a tiny point where it all began, but what comes next? Well, many have pondered that question. Some propose a fresh start with a new Big Bang, while others envision a universe exploding like a bubble in a different location. Some even speculate that this process repeats, giving rise to countless other universes. Scientists have questioned why we seem to perceive time as going ahead in this matter. Some argue that time is, again, just a human construct and suggest a block universe where space and time are interconnected in a four-dimensional structure called space-time, which aligns with Albert Einstein's general theory of relativity, which holds that each event has unique space-time coordinates. According to this perspective, the present exists alongside the past and the future. Physicist Max Tegmark from the Massachusetts Institute of Technology seeks to address this notion. He proposes two ways of portraying reality: as a three-dimensional place where events unfold over time, or as a four-dimensional space-time where nothing changes. If the latter picture holds, then time becomes an illusion because everything, past, present, and future, already exists. At any given moment, we perceive the past as having occurred and the future as having yet to come, and we experience change. Julian Barber, a British physicist, likens this to a series of nails. We are only aware of our brain state, and the illusion of a past arises from our memories. We were taken on a mind-bending voyage across the spheres of time, the spheres of cosmology and culture, by Dr. Barber's intriguing chat with author and scientist Adam Frank. As we ponder our existence, we find ourselves moving through a series of moments, like stepping stones in an unknown landscape. These moments, Dr. Barber explains, can be visualized as a country he calls Plutonia, a timeless realm governed by precise mathematical rules. But what about the past do we hold so dear? Dr. Barber reveals that it might be nothing more than an illusion crafted by our minds, which leads us to revisit the theories of renowned Albert Einstein, particularly his groundbreaking concept of space-time. However, as with literally any revolution, doubts and questions always arise. So, what if Einstein's theory is not the ultimate answer? Could letting go of the concept of space-time actually help us understand the cosmos better? And then came Isaac Newton, who introduced us to gravity, explaining how planets orbit the sun. And for centuries, his theory ruled supreme until the arrival of a scientific prodigy named Albert Einstein, of course. Classic rivalry between two people that existed at different times. In 1915, Einstein unleashed his general theory of relativity, which portrayed gravity not as a force, but as the curvature of space itself. Suddenly, everything fell into place. Newton's theory yielded a new understanding of the universe. Einstein's space-time theory reigned unchallenged for over a century, capturing the imagination of scientists and the public alike. However, the discovery of gravitational waves in 2015 marked a turning point. This breakthrough clashed with another powerful theory, quantum physics. In the quantum realm, particles can exist in multiple states simultaneously, defying our everyday intuition. Yet, this conflicts with the smooth fabric of spacetime described by Einstein. The renowned theoretical physicist Sabine Hossenfelder candidly admits that this conundrum is embarrassing, as gravitational fields cannot occupy multiple places at once. As physicists look for a ground-unifying theory that harmonizes these two competing theories, the endeavor to reconcile general relativity and quantum theory takes on a greater importance. Here comes the intriguing theory of strings, which claims that subatomic particles are made of microscopic vibrating strings. Just as strings on musical instruments make different notes, these strings give rise to different particles. General relativity and quantum physics may be reconciled by string theory, but this requires an expansion from 4 to 11 dimensions. Although intriguing, experimental proof of these additional dimensions is still very difficult. Seeking alternatives, physicists explore loop quantum gravity, LQG, which challenges the notion of smooth spacetime. LQG claims that spacetime is made up of intertwined loops, similar to the stitches in fabric or the pixels on a screen. However, these defects in spacetime only manifest in the unimaginably tiny Planck scale, making them incredibly difficult to detect or study directly. To truly investigate this scale, we would need a particle accelerator far more powerful than the Large Hadron Collider, the LHC at CERN, a machine stretching across our entire Milky Way galaxy. The enormous difficulties that still need to be overcome in order to solve the puzzle of spacetime and reconcile quantum physics and gravity only serve to heighten the attraction and excitement that already surround the field of theoretical physics. So, now let's dive into an intriguing tale that might just reshape our understanding of the universe. A team of brilliant physicists from the UK, France, and Hong Kong are on the verge of unlocking a whole new way to discover the mysteries of gravity. Their secret weapon, their secret sauce, you might be asking? An ultra-cold gas comprising billions of cesium atoms is known as the Bose-Einstein condensate. These physicists are questioning everything about reality itself. They want to know if gravity, the force that holds everything together, could have a quantum nature, and they believe that by studying this peculiar state of matter, they might actually finally uncover the answer that they've been seeking. But wait, there's more! As we gaze out into the vast expanse of the universe, another clue presents itself. Light, traveling billions of light years, carries with it the potential to reveal tiny imperfections in space and time. While each defect may seem tiny on its own, the cumulative effect of interactions with multiple defects could give rise to observable phenomena over those unfathomable distances. For the past decade, astronomers have focused their attention on far-off gamma-ray bursts, cosmic fireworks signaling the death of big stars. But there's a strange mystery behind these mysterious explosions. Their spectral characteristics seem to contain a distortion that defies our existing knowledge. Is it the result of their long journey through space, or is it something inherent in the bursts themselves? The jury's still out as we wait for clear-cut answers. Let's take a step back and revisit one of the fundamental ideas put forth by the great Albert Einstein. According to him, space-time is like an unyielding stage, where celestial objects dance and perform their cosmic routines. It exists regardless of their presence, a backdrop to the grand cosmic theater. But Laurent Friedel, Robert Ley, and Jordi Mink dare to challenge this notion. Their bold theory holds that space-time is a byproduct of the entangled interactions between objects rather than an autonomous entity. They suggest that the mysterious universe of quantum physics, which is organically connected to it, gives rise to space-time. Although it may seem, strange, it gives a clear and exciting solution to the current puzzle. But, my friends, now is here where truly things get interesting. This new theory of modulus space-time holds the promise of resolving another long-standing puzzle in physics, the baffling little phenomenon of quantum entanglement. Picture two particles brought together, then their quantum properties intertwined. Separated by vast distances, they remain intrinsically connected. Change one particle's properties and the other instantaneously responds, seemingly defying the speed of light. Einstein himself found this spooky action at a distance deeply unsettling, yet the theory of modulus space-time might just provide an elegant solution. By redefining this concept of separation, it suggests that proximity in the quantum realm holds greater significance than physical closeness. Different observers may perceive locality differently, depending on the context. It's a confusing notion that challenges our very understanding of space, time, and the interconnectedness of the quantum world. For the past 5 years, Friedel, Ley, and Minnick have been diligently honing their groundbreaking theory. Step by step, they are venturing into uncharted territory, exploring a gravitational quantum world unlike anything that we've ever imagined. Their approach sets them apart from the conventional path of quantisizing gravity, and it holds captivating potential. But remember, no scientific theory is complete without rigorous testing. This trio of brilliant minds is actively working on incorporating their ideas into a comprehensive model, ready to subject it to the crucible of experimentation. It may seem like a concept reserved for deep thinkers and academics, but truly, its implications could reach far beyond the confines of a lecture hall. This challenging revelation has the potential to shape our daily lives in ways that we never thought was possible. So, hold on tight, because the stakes are higher than you could have ever imagined. I guess I probably shouldn't assume that for you, but they're higher than you probably imagine. Our modern world, filled with technological marvels, operates seamlessly thanks to the principles of quantum theory. Everything from our smartphones to medical advancements relies on this intricate web of knowledge. It's why we're delving deeper into the quantum structure of space-time, and it's why we could unlock groundbreaking technologies in the future. Sure, it will not, and I stress, will not happen overnight. We're not talking about a radical shift in the next few decades. No, we're envisioning a future, perhaps 200 years from now, where our enhanced understanding of space-time becomes the driving force behind unimaginable innovations. We won't be living in the same planet, really. In the vast arena of theoretical physics, a champion has reigned supreme for quite some time now, but as the days go by, cracks begin to appear in its once invincible armor. It's a sign that change is on the horizon, and a new contender is eagerly waiting to claim the throne. Stage is set, competition is fierce, and a multitude of contenders step forward, each with their eyes on the coveted prize. But this ain't just any ordinary succession. It is a battle that holds the potential to revolutionize the very fabric of our own understanding. The moment a worthy successor rises to the occasion, we could witness a seismic shift in the realm of theoretical physics. The implications? Well, they would stretch far and wide, transcending the boundaries of our current knowledge. Imagine a world where our perception of the universe is forever changed, where new theories and concepts reign supreme. The fruits of this transformation are not confined to the realms of academia alone. They have the power to touch the lives of every person, every man, woman, and child, unlocking mysteries and expanding the horizons of human knowledge. But here's the burning question. What is the next move for astronomers, scientists, and physicists in light of this astounding revelation? God, what's the next move for any of us? Anyways, we are dying to hear your thoughts. Drop them down in the comment section down below, and let's keep this cosmic conversation going. Are we on the verge of rewriting the laws of time, or is there something else at play?